Imagine one day you woke up in your bed. The room looks familiar and the day feels normal. People around you may even be speaking or moving around, but something is different. You can't get up and out of bed. You're unable to move and also find that you're unable to speak. The drive to do anything, take any action, has completely disappeared. This condition is called akinetic mutism. It is a rare neurological state that causes an individual to be stuck in their body without the ability or will to take any voluntary actions. Luckily for us, this does not just happen out of the blue. There's actually a section of your brain that controls your will and motivation. This part is called the anterior cingulate cortex, and it's located inside the frontal lobe. The ACC is described as being the central hub of decision-making, willpower, and motivation, with its subregions having a hand in emotional regulation, reward analysis, and executive function. Here's how that works in reality by seeing the things that need to happen in your brain in order to decide on a goal, like going for a bike ride or staying home and watching TV. The ACC starts by looking at things like your energy levels or the weather outside. If it finds that the weather is nice and you have energy, then it might decide a bike ride is the better option. The ACC then asks the orbital frontal cortex to proofread the plan and assign it a value based on how enjoyable or beneficial it thinks going for a bike ride will be. The ACC then sends the OFC's evaluation to the midbrain, where the dopamine system provides the needed energy and motivation to initiate the task. The ACC then lets one of its subregions, the dorsal region, take over and turn the broad goal into a set of specific tasks like changing into workout clothes, grabbing your water bottle, and selecting a path to ride on. You then start taking the physical actions needed to complete the ride as your ACC and OFC monitor your progress. Once the bike ride is finished, the OFC signals that your goal has been met, and the dopamine system communicates this to the ACC via the reward prediction system, which reinforces the bike ride option, making you more likely to pick it in the future. As you can see, mustering up the will and motivation to do something relies on the ACC sending out lots of complex signals to other areas of the brain and receiving their feedback. But what happens if that system breaks down?
The ACC's development. The ACC's development begins at 4 months old and does not finish developing until our mid-20s. This means our ACC is under construction for nearly a third of our life. This provides quite a window for both genetic and environmental influences to shape its function. A huge influence on the structure of the ACC is its early childhood environment. Repeated childhood experiences of stress, trauma, or neglect can cause a flood of cortisol, also known as stress hormones. This leads to thin grade matter and cellular death in the ACC, resulting in a decrease of structural activity. This means that there are less neurons in the ACC and impulse control is now compromised. This makes the possibility of substance abuse quite a bit higher, which leads me to my next point, and I'm sure you have already guessed, substances, one of the most devastating things that can affect the ACC's development. Cannabis disrupts a specific neurotransmitter system associated with learning, memory, and neuroplasticity. Less glutamate and glutamine within the ACC caused by the use of cannabis is linked to impaired conflict management and poor ability to prevent impulsive actions. Methamphetamine has different effects. The mitochondria, also known as the energy center of your brain cells, gets overworked. This damage mirrors the impulse control and conflict management issues we saw in young cannabis users. Plus, you have a significantly harder time paying attention and focusing. Yikes. This has been proven with a cognitive test called the Stroop Color Word Test. The Stroop Color Word Test is a test where participants must say the color that a specific word is written in but the word is also a color, so it requires focus to do so correctly. Take a look at the top of the photo here. When you read the top half, you will see how intuitive and easy reading the colors that match the color of the font are. But look below and try saying the color of the font rather than the word itself. I'll give you a moment to try and do so. You will see it is challenging to do this, which is exactly the point. It reveals a person's ability, or lack thereof, to focus and suppressed impulses. Even more interesting, the age of exposure to methamphetamine has a stronger implication of future addictive behavior than the dosage amount does itself. This damage does not simply go away after you stop taking substances. It is like stepping in wet concrete. The ACC is still going to continue its development, just like that concrete is still going to harden and dry, but both will misshapen at the end of it.
Now that we know what the ACC does and how it functions when damaged, let's circle back to what happens in extreme cases when you lose all free movement and internal drive, a condition known as akinetic mutism. This is not the same as being unconscious, and it is not the same as simply not wanting to do something, like chores or homework. It is the breakdown of your central decision-making hub that drives everything you do. One very well-documented example we can find of this condition is from a 72-year-old man who developed it after a severe frontal lobe injury due to an electrical grinder incident. Doctors continued to monitor his behavior months after the incident, and what they found was that he spent all day lying in bed, without speaking or initiating any sort of movement at all. The man was awake and conscious, but could not start a conversation, get out of bed, or engage with his surroundings. Externally, he was healthy and would be moving in normal circumstances, yet because of this injury, he was left trapped in his body. When the ACC is severely damaged, communication pathways between motivation, reward, and action begin to break down. Oftentimes, the individual is fully awake and aware of what is happening within their surroundings, being able to use senses like hearing and seeing, as well as understanding the conversation that takes place around them. The issue lies within the absence of internal drive that is needed in order to respond. Lacking the internal drive necessary to respond, the reality that patients with this condition face is to watch their lives unfold without the ability to autonomously participate. The ACC can be thought of as a bridge between our thoughts and the actions following those ideas, but damage to the ACC effectively disconnects our intention from behavior. Damage to the ACC demonstrates just how vital this part of the brain is for us, because when it functions properly, we rarely notice it. However, when the system breaks, we are very strictly reminded that even simple functions rely on an incredibly intricate network of neurons inside of our brain. These basic actions you take without a second thought, studying, reading, or getting out of bed, are all closely tied to the ACC helping turn your thoughts into action. Motivation is commonly thought of as a personality trait or a self-discipline, but we can see through the ACC that it's deeply rooted in our biology. Thank you for watching.